Okay, so our next problem is this. It's a little bit more complicated problem, but I think we're ready already to solve this. So Michelle deposited $400 at the end of every month for 6 years. For the first 4 years, the rate was 3% compounded monthly, and for the remaining 2 years, the rate became 2% compounded monthly. How much did she accumulate at the end of 6 years? Okay, so that's the problem. Let's see how our timeline would look like for this problem. So we have now time. So let's just make a little bit of clarity here, okay? So one thing you need to notice is that rate changed here, right? And remember when we talked about annuities, for us to have one annuity, we have to have same payment, same rate, and also same time. Okay, so in here we have same payment, $400 payment is the same all the time. So then we have same intervals, which is monthly. So at the end of every month, for all 6 years, the payments are happening. But we have a rate changing, which means that we cannot consider this to be one annuity for all 6 years because the rate changes in between, right? After 4 years, the rate became 2%. So now, on this timeline, let's just put plus 4 years first. And then here somewhere plus 6 years. So which means that, and it's today, right? So time 0 is today. So which means that for the first 4 years, we are having an annuity in which the rate is 3% compounded monthly. But actually, for the second part of this, transaction, the rate becomes 2% compounded monthly. So, and this is the crucial thing because in reality, in this problem, we encounter two annuities. One annuity where rate is the same. That first annuity is active for this first 4 years. That's our first annuity. And then we have a second annuity because now for that second part of this transaction, we have the same rate. So once again, because our rate changes from one to another, we cannot say that it's one annuity for all 6 years. We have to split this annuity into two annuities. Each of those annuities is active in its own time periods, okay? So this first annuity will result in a future value, right? So let's just call that future value 1, okay? And what is really important to realize is that that future value of that first annuity, the one with 3% compounded monthly, so that future value of the first annuity will be as of 4 years from now. What that means is that Michelle, when she waits for 4 years, if she actually checks her account at the end of 4 years, she will see future value 1 there, which is the future value of her first annuity. But then when the rate changes, she will continue paying her $400 at the end of every month, right? So then at the end of 6 years, that second annuity, which is active from the end of 4 years up to the end of 6 years, so that second annuity will result in future value 2. Okay. So it's as though Amy had basically invested first for 4 years, right? Then she accumulated some amount of future value 1, which she will leave in the account, and then she basically activated another annuity for the remainder of the term, for the remainder of those 2 years, right? And then she would accumulate separately future value 2, okay, from that second annuity. Now, what is really, really important is to realize that after this first future value will be accumulated, it will be remaining in the account, it will be staying in the account for that extra 2 years, right? So Michelle will not pick up this future value 1, she will leave it in the account for the remainder of the term for those 2 years, simultaneously with the fact that she will continue paying for that second annuity, right? So therefore, this future value 1 has to be transported to future, as we say in financial mathematics. In other words, what that means is that future value 1 will become a present value for a regular investment, right? So that future value 1, that amount of money that Michelle will find in the account at the end of 4 years, that amount of money will continue to grow just like a regular investment for 2 more years, and it will become modified present value. So this modified present value, it will become modified future value, and that modified future value we will call future value 1 star. Okay, future value 1 star is that future value 1 which has accumulated interest over 2 more years. Now that's just a general plan. Of course, we will now take that future value 1 star and we will add with future value 2, and that's how we will find out how much money in total will be there after 6 years. Okay, so that's very important to realize the mechanics of this problem. And once again, just to stress, okay, a lot of students make this mistake. They would find, okay, so there are many mistakes which are possible in this problem. One mistake which is possible is that you find basically one future value for the whole 6 years and ignoring one of the rates. That's a very bad mistake because you cannot just ignore the rate. Another mistake is to find future value of the first annuity, future value of the second annuity, and just add up those two numbers. You cannot do that because these two numbers are separated in time, right? So future value of that first annuity is 4 years from now, future value of that second annuity is 6 years from now. You cannot simply just add them up. In order for you to add them up, you have to put them to one time, which is 6 years from now, right? So that future value 1 will still continue to grow in the account for 2 more years, and only then you will be able to add these two future values. One modified future value and another the future value of that second annuity. So, but let's see how this will work in actual calculation. So on this timeline also I'll say that it's $400 payment, right? So PMT is $400 here, and in this part PMT is still $400, right? So that's for you to see that payments do not change here. It's only rate changes, right? So in this first annuity, PMT is going to be $400, and then the second annuity, which is induced by the changed rate, the PMT is also $400, okay? So now I can erase this problem and we'll use this graph for us to, we'll use this graph for us to navigate through the solution, okay? So let's execute all this process and let's see how this will look like using mathematics. Okay, so we need first to find future value 1. Once again, what is that future value 1? Future value 1 is the future value of that first annuity when the payment is $400 and when the rate is 3% compounded monthly. Future value 1, that's the ordinary simple annuity of $400, which is the payment, which will grow for 4 years, right? So now the rate is 0.03 divided by 12. That's the periodic rate. How many payments in total? Well, 12 times 4, right? Because 12 payments per year for 4 years minus 1 and 0.03 divided by 12. That's our future value 1. So let's calculate this. So this is 20,372.48 337. I will keep all decimals right now because I have to reach the final stage of the solution for me to be able to round. Okay, so I keep full decimals right now. Now, what that really means is that at the end of 4 years, that's how much will be registered in that account due to that first annuity, right? So that first ordinary simple annuity will give you this future value, which we call future value 1, okay? But what is important to realize is that that future value 1 at that moment will become a present value, which will grow for 2 more years, okay? Because that will stay in the account for 2 more years. And on top of that, remember, second annuity will start as well, okay? But speaking about this first annuity, that future value, which will be this one after 4 years, that amount, this amount will continue to grow for 2 more years just as a regular investment, not as an annuity, okay? So for me to find future value 1 star, I have to use this formula. So I will be using this formula now, just to remind you. Basically what will happen is that this amount, future value 1, will actually become present value in this formula, okay? Because that will be the amount basically invested at that moment, which will continue to grow for 2 more years. So let me do that and calculate this future value 1 star. Okay, so that will be 20,372.48337, right? So all this amount will be invested at this period, the same, actually, which is extremely important. I almost ignored the fact that the rate becomes 2%, so we have to invest at now 2% compounded monthly, and that's a very important moment here, right? So then when this amount continues to grow, now the rate already is different, right? And we have now 2% compounded monthly for the remainder of the period. Now it's going to be 12 times 2, okay? So let's calculate this. So this will result in 21,203.19418. Okay, so look, what this really means is that if you ignore that the second annuity really exists, this means that if Michelle invested $400 for the first 4 years and then basically left that in the account for 2 more years, what that means is that Michelle simply would earn would have in that account 21,203 and so on at the end of 6 years. Okay, but we should not forget that in this problem we also have the second annuity. Right? We have also the second annuity, which moves, which is calculated using 2% compounded monthly in the rate, and basically that second annuity is there simultaneously with the fact that that future value 1 was growing for those 2 years. Okay, so let's now calculate future value 2, future value of that second annuity. Well, that will be. Now let me actually erase this. Already we know the information. So it's $400 12 times. So now the rate is 2%, right? So for the second part, the rate is 2% compounded monthly, and that is happening for 2 more years, right? So minus 1, 0.02 divided by 12. So this gives me 9,786.268701. So that second annuity would give me this accumulated value. Now what I should do, I should take the amount of money I have from my first annuity, adjusted for 2 more years, and add future value of my second annuity, right? So that will be my answer. So let me do that. I kept all these digits in the memory of the calculator, so it's not that difficult for me. So the total, let's call that total future value, will be future value 1 star plus future value 2, right? So which is 30,989.46. Now, at the very last stage, I can round to 2 decimals, right? And that's an important point to keep in mind. Do not round anywhere in between until you reach the final answer. That's important, okay? Because if you round somewhere in between, your actual final answer will be different. Keeping in mind this, still there are situations that you should round in between, okay? So for example, in this situation, if Michelle invested $400 for the first 4 years, and then she actually physically refreshed her account after the end of 4 years. So she physically removed her money from the account and put it back in. So at that moment, if that happened, of course, she would have to take away amount rounded to 2 decimals, right? So after 4 years, Michelle would remove this amount with 48 cents, so rounded. And if she put back immediately for that amount to grow for 2 more years, of course she would put back rounded value to 2 decimals, right? But if she doesn't physically really interfere with that account, and if it just works automatically, the bank will not round anything. It will continue with all the decimals, and the rounding will happen only when Michelle actually picks up that amount at the end. So that's how we solve that more complicated problem. So now let's proceed to the discussion of what to do if the annuity is general. Okay, so I remind that annuity is general when your rate compounding frequency is not the same as your payment frequency. Okay, so let's consider this example. Okay, let's say Sam invested $3,000 at the end of every month into an account earning 5% compounded monthly. How much will he accumulate at the end of 4 years? Okay, so look, this annuity is of course not general. That's a simple annuity. Why? Well, first let me read this again. So Sam invested $3,000 at the end of every month into an account earning 5% compounded monthly. How much will he accumulate at the end of 4 years? So you see, this annuity is of course simple. Why? Because the rate is compounded monthly and the investment is made at the end of every month, right? So that's a simple annuity, not a general annuity. So I promised to you to speak about general annuities right now, okay? But first, before we do so, let's remind ourselves how we would solve this problem for a simple annuity so that you see later on what kind of modification has to be made for this to be making sense for general annuity, okay? So if this, and that is a simple annuity, so we can find future value, and it's also ordinary annuity, by the way, which makes the use of our formulas possible. So you have $3,000 and 1 plus 0.05 divided by 12, right? So 12 times for 4 years, so 12 times 4 minus 1, and we divide by that rate, okay? So that's how we would go about calculating this future value. I'm not going to compute this right now. Why? Because I wanted just to remind you how this system would look like for the simple annuity. Now, let's say in this problem we will make a modification. So instead of compounded monthly, I would, let's say compounded daily, okay? So now our rate has become compounded daily, and this will make immediately annuity general. Why? Because the payment is every month, so 12 times per year, but the rate is compounded 365 times per year. So 365 is not equal to 12, therefore this annuity is general. Another way to look at it, we know that this annuity is general because it's not simple, okay? Now, you see, the thing is that this kind of solution would be right away a mistake for this problem when the rate is compounded daily. Why? Because I cannot do this, right? I cannot take 5% and divide by 12. It's not any longer a periodic rate, a proper periodic rate, because now the rate is 5% compounded daily, right? But even if I do divide it by 365, that also will not be proper, because that will be the using of this formula for the incorrect situation. Remember, this formula is only valid for ordinary simple annuity. If annuity is general, you cannot directly use this formula, even if you divide 5 by 365. Okay? So there is only one way out of this. There is only one way out of this, and this way is to convert the rate. What we should do, we should take this 5% compounded daily and convert that rate into a rate which is compounded monthly. And we already know how to do this from lectures from before, right? So that is finding I2, the rate which is equivalent to the rate which is compounded monthly but equivalent to 5% compounded daily. So in order to solve this problem, we need to have some step 1. So let's call it step 1. And step 1 is about finding I2, rate which is compounded monthly and which is equivalent to 5% compounded daily. I'll remind you that this calculation of I2 is 1 plus I1, right, which is in this case this initially given rate, but a periodic version of that rate, M1 divided by M2 minus 1. That's the formula we already discussed when we talked about the topic of equivalent rates. Okay? So sometimes this subscript 1 is not written, just because, so we do write I2 as our second rate, which will be equivalent, but this subscript 1 is omitted sometimes, just because, this implies that that's the first rate which is given here. Okay, so if I now use this formula to find this I2, let me do that. I2 will be 1 plus 0.05 divided by 365, right? So 365 divided by 12 minus 1. So what I'm doing now, I'm converting this 5% compounded daily to an equivalent rate. I'm finding an equivalent rate compounded monthly, and that I2 will be the periodic rate for that. Now, if you are not comfortable with this, if you forgot this, go ahead and watch that lecture about equivalent rates, because that's going to be very important for us for solving for general annuities. Absolutely do not continue listening to these lectures until you basically review this very properly, okay? Because otherwise you'll be confused. So from now on, I will assume that you understand what I'm talking about, that you already went back to that lecture, basically reviewed that topic, okay? Now, let me compute that. So this will be 0.004175.073. So that's I2. Okay. Now let's analyze very carefully what happened right now. So I found this I2. Now this I2 is a periodic rate. So this rate now is per month, right? So it's a periodic rate per month, which is compounded monthly as well, right? So that's, and this rate compounded monthly is equivalent to 5% compounded daily, right? So in other words, basically in this problem, I can replace this 5% compounded daily by this rate per month compounded monthly, okay? What this does, it actually changes this annuity from general to simple. So if I use this rate now, this annuity will become simple, okay? That's very important. Why does it become simple? Well, because now our rate is compounded monthly, okay? So that's why this annuity is now a simple annuity. So with this rate, we can now calculate, we can proceed to our step 2 and calculate the future value, okay? So now this future value will be this $3,000, so this payment, 1 plus I2, you see, I'll use this I2, which is already a periodic rate. So keep in mind one thing, so some students are confused here because they would take this number and divide by 12, okay, which is not necessary because it's already periodic rate. It's already a rate per period. So you use I2 here in the formula as already a periodic rate, but properly compounded. Now, it's compounded monthly, so it's 12, right? And this loan is for 4 years. 12 times 4 minus 1, and you divide by I2 again. So we now, in step 2, we use future value for ordinary simple annuity. For ordinary simple annuity, and why we use it for ordinary simple annuity? Because that annuity is already simple with this new rate I2. Okay, so let's now, I will keep this rate in the calculator memory for easy calculation. So it will be 159,077.01. 159,077.01. Now, please keep in mind very carefully that I never rounded this rate. So once you find this I2, don't round this. That's very crucial. Because if you round this rate somewhere, right? For example, if you do like 0.004, and that's it, if you drop all that stuff, so that will affect your solution quite a bit here, right? So put unrounded value here. That's very, very important. Okay, so that's how we solve for general annuities. We simply convert the rate and make our annuity simple again. So let's consider more examples. So in our next problem, we have Steve who can draw 1050 at the end of every quarter from his account for 6 years. How much is the account balance if the rate is 5% compounded monthly? So Steve has some money in the account, and that money, of course, earns interest over time. And Steve takes 1050 from that account for 6 years, right? So we want to know how much money is that, how much money is in the account, which allows Steve to take 1050 for 6 years. Well, if you look at this problem, you will notice right away is that the rate is compounded monthly, so 12 times per year, but the money will be taken at the end of every quarter. So it's ordinary general annuity because the money will be taken 4 times per year, but the rate is compounded monthly. Okay, so because it's a general annuity, we'll do the same thing. We will have to convert the rate to make that annuity simple. Okay, so what we need to do, we need to take 5.5% compounded monthly and find equivalent rate to this one, which will be compounded quarterly. Okay, so this will entitle us to find this I2, and this will be 1 plus 0.055 divided by 12, 12 over 4 minus 1. Okay, so then if I calculate this, so this is going to be 0.013813117. So we have found this I2. Just again to reiterate this point, this I2 is the rate per quarter, right? So this is the rate per quarter, compounded quarterly. Okay, so that's a periodic rate, but the major thing is that it's a rate per quarter and it's compounded quarterly as well, right? So this is the periodic rate which makes this annuity simple, because after we replace 5.5% compounded monthly with the rate which is compounded quarterly, the annuity becomes simple. Okay, and also never forget that that's a periodic rate, it's not a nominal rate, right? So let's find present value. In this problem we are interested in present value because that account balance is there today, and Steve will be drawing from that amount in future. So present value will be the payment, which is 1050, okay, and it will be 1 minus 1 plus I2 minus, it's compounded quarterly, so 4 times per year, times how many years? 6, right? So because that's the compounded quarterly rate already, so you just and because that's already a periodic rate, you put it there in the formula as a periodic rate, right? Don't divide it by 4, okay? And then you divide by I2. So let's calculate this. 21,324.71. Okay. So Steve has this much money in the account, and from that amount he can draw 1,050 at the end of every quarter. Okay. Okay. Just to refresh our memory, let's also answer another question, which is how much interest will be included in all the payments, right? So let's ask a question about interest. Okay, so I remind you that in order to find interest, you will take your all your payments combined, because it's a present value here involved, right? So now in order to find interest, you need to compare all your payments combined with that present value. So all your payment combined will be 1,050 times how many payments is that? It's times 4 per year times 6, okay? So that's all the payments combined minus 21,324.71. So let's calculate that. Okay, so we have 3,875.29. So that will be the interest included in all the payments combined in this problem. So this problem reads, Jonathan invested $10,000 today and also decided to invest additional $1,000 at the end of every year for 5 years. How much money will Jonathan have in 5 years from now if the rate is 6% compounded semi-annually? So in this problem, what is happening is that you have a timeline, right? So today is time 0. Jonathan invests $10,000 today. On top of that, at the end of each year, plus 5 years, I'm sorry, so plus 5 years. On top of that, Jonathan also will invest $1,000 at the end of every year. So the question is, at this moment, how much money will Jonathan accumulate? Okay, so what is important to realize here is 2 things are going on in this problem. First is this $10,000, this investment will grow just like a regular amount for all 5 years, simultaneously with the fact that also annuity will generate future value here, right? So annuity also will generate some amount of money. So let's denote this $10,000 that grows for all 5 years. Let's denote it future value, simply just future value like this, right? So this $10,000 will become future value, okay? Now this annuity will grow to, call this annuity, let me just, use blue marker maybe to differentiate this annuity from this bulk investment here. So this annuity, all these payments of the annuity, they will give Jonathan future value of annuity. So I'll use this A here this time to make sure that we distinguish this future value from this regular future value of that $10,000. Okay, so this total accumulated amount of money after 5 years will be the sum of future value and future value of annuity. Sum of future value of $10,000 and future value of annuity. Okay, so let's now execute this plan. But we also need to keep in mind that in this problem, the rate is compounded semi-annually. So the rate is compounded every 6 months, 2 times per year, whereas the payments are every year. Okay, so which means that this annuity is going to be general annuity. Now, and it's also ordinary annuity. So we can use our formulas after we change the rate. Now, let's change the rate. Let's find I2. One plus 0.06 divided by 2, because that rate 6% is compounded semi-annually. So 2 over 1, okay, because we want a rate which is compounded annually. You also might wish to review what we talked about when we spoke about effective rate, right? So effective rate is the rate compounded annually. We also spoke about how we also spoke about some simplified formulas for effective rate. But you can always use this I2 as your general formula. Okay, so this I2 will be computed now. So it's 0.0609. Okay. So in essence, you have here periodic rate, which is the same as nominal rate in this problem because that rate is compounded annually, right? And it's the same as effective rate actually. So we have this I2. Now let's calculate the future value of annuity first, okay? So future value of this annuity is $1,000, 1 plus I2, so we have 5 periods minus 1, and we'll divide by I2. So let's do that. So 5,647.23. But I will not round this actually. I'll keep it all decimals because this problem is complex. We still need to work with this. And it's, by the way, future value of annuity, right? So we still need to work with this $10,000 later on. So we need fully unrounded value. Okay, so we found future value of general annuity. We converted the rate. We went from rate which was compounded semi-annually to the rate which is compounded annually. Okay, and with that rate compounded annually, annuity became simple, and we basically could find future value of that general annuity. Okay, so let me erase this now. So now we need to find future value of that $10,000. You know. So future value of that $10,000 will be, oh, it's not annuity anymore, right? It's a general investment, so keep that in mind. So $10,000 is 1 plus. Now a question arises, what rate should you use? Should you use 6% compounded semi-annually, or should you use I2 for that $10,000 investment? Well, because I'm going to find that future value of $10,000 not as an annuity. That's not an annuity. That's just a bulk investment which grows. I'll be using this regular formula for compound future value. And you will need to realize, because that investment is not annuity investment, it doesn't really matter. I can use I2 or I can use 6% compounded semi-annually because these rates are equivalent, it doesn't matter. But I will still use I2 simply because, you know, it's already in my calculator and it's just more straightforward. So I2 times 5, right? So that's rate per year, basically, and I have 5 years here. So this will be 13,439.16379. Okay. So answer total, basically total that will be in the account is future value A plus future value of the annuity plus future value of this bulk investment. So that's what I will do now. Adding those unrounded values, and I'll get 19,086.39. So that will be the solution for that problem. Okay. Now, maybe a good question to ask is, what is that total interest earned in this situation? Okay, so let's just ask that question and try to answer this. So what is interest earned? Well, in this case, it's not only annuities, also $10,000 that gives us interest, right? So interest in this case will be the amount of money that we actually accumulate, right? Which is 19,000 86.39 minus 10,000, which is your original which is the original $10,000 investment, right? Minus all payments combined, which is 1,000 times 5, right? So there are also $5,000 worth of payments, right? So basically, we remove $15,000 from this transaction, so it's 4,086.39. So that will be the interest earned in this transaction. So just to keep in mind here is that $10,000 also was taken into account here because it also accumulated interest over this time. Okay, so just to summarize so far what we achieved. Let's draw an annuity, we can call it a diagram, right? Annuity diagram. So we can have, when we have any annuity, we can end up with a general annuity, and also we can end up with simple annuity. So when we have an annuity, it's either going to be general or simple to begin with, right? Also, it can be ordinary or due, but that's a little bit another story for now. So annuity can be either general or simple, okay? So now what we learned to do is that as soon as you encounter a general annuity, you can always change that general annuity to simple by you just need to find I2, okay? So as soon as you find I2, your general annuity becomes a simple annuity and you have no more general annuity, right? So that will be simple annuity. So what we'll be doing next time is exploring what would you do next, okay? Because that simple annuity that you found can be, you can end up with still a due annuity or ordinary annuity, right? So far today, we always had this situation. Annuity was either general or simple today, but then it always was ordinary. And that's the reason we could use those formulas for future value or present value. Because remember, one of the major things to take away also is that those formulas for future value or present value of annuity can be used only for simple ordinary annuity, right? So today we only had ordinary. But going forward, we also will need to explore what to do with due annuity so that we can complete this decision-making tree and know how to solve for any kind of annuity. But at this moment, bye for now, until the next class.